All right, today we're going to build a detective. But not a person. We're talking about an AI, one that's specifically trained to hunt down the most slippery culprits out there on the internet, deepfakes. This is the story of what's being called the progressive deepfake detective.
You know, we're already living in a world where AI can cook up images, videos, even audio that looks and sounds completely real. I mean, totally indistinguishable from the real thing. And that brings up a really big question, right? When you can't even trust your own eyes and ears, how in the world do you find the truth?
Well, it turns out a group of scientists has a plan for that. They've actually created a blueprint for a whole new kind of investigator, a digital detective, built from the ground up with one mission: to expose AI manipulation. And today, we're going to walk through that blueprint step by step and see exactly how they pull it off.
Now, this detective's training, it's not just random. It's this super structured 10-phased experiment. And what makes it so cool is that each phase builds directly on the one before it. It literally takes our AI from being a complete rookie to a seasoned pro. Yeah, think of it like a full-blown training academy, but for an algorithm. So, every journey has to start somewhere, and this one begins with basic training. These first few phases, they're all about learning the absolute fundamentals. You know, how to see, how to listen, and how to start connecting those crucial dots. This initial training is basically a 3-step crash course. First up, in Phase 1, baseline testing, our rookie detective gets thrown right into the deep end. It's tested against this huge data set to figure out, okay, where are my weaknesses, what are my blind spots? Then comes Phase 2, adapting to reality. It takes what it learned from its failures and starts training on real-world examples. This is where it gets way better at spotting new fakes, even with just a little bit of evidence. And finally, in Phase 3, it learns how to fuse the clues. This is huge. It starts combining evidence from everything: video, audio, and even really subtle things like weird blinking patterns. Put it all together, and this basic training pretty quickly turns our rookie into a really capable analyst.
Okay, basic training is over, but now comes the hard part. It's time to get our detective ready for the real world. You know, the messy, chaotic, and sometimes downright hostile world of the internet. It's got to learn how to survive on the digital streets.
So this advanced boot camp really boils down to 2 missions. First, you got to make the detective tough enough to handle intentional attacks. That's called adversarial robustness. And second, you have to make it fast and efficient enough for the real world. That's lightweight optimization. So Phase 4 is all about teaching it to see through what you could call digital camouflage. Things like video compression, background noise, and all the other little tricks people use to hide deepfakes. This makes it way more resilient. Then in Phase 5, the model gets optimized. I mean, what good is a brilliant detective if they take forever to solve a case, right? This phase makes the AI super lean and fast. So fast it can run on everyday devices, maybe even the smartphone in your pocket.
So at this point, we've built a detective that's actually pretty good at spotting fakes. But that's not enough, is it? To really trust it, we need to know how it thinks. This next part is probably the most advanced piece of its training. It's all about building trust and teaching it to actually reason, not just match patterns.
And this involves 3 final, really important steps. First, in Phase 6, the detective learns to show its work, to be explainable. It's not a black box anymore. It can actually generate visual proof, like painting a heat map over a video to show you the exact pixels that made it suspicious. That kind of transparency, it's absolutely crucial if we're ever going to trust its judgment. Next up, Phase 7 is a real game changer. Our detective now learns to use 2 different methods at once. On one hand, you have AI detection, which is all about analyzing the pixels themselves, what the image looks like. But now it adds something called digital provenance. Think of this like checking the official paper trail. It's looking for secure cryptographic watermarks that prove where the image came from. So now it has 2 totally independent ways to get to the truth. And then in Phase 8, it gets a huge intelligence boost. It learns to understand context. It starts spotting high-level issues like shadows falling in the wrong direction. It's not just a simple pattern matcher anymore. It's actually starting to reason.
And with that, our detective has graduated from the academy. Its core training is complete. So now it's time for the final exam. Let's see how it did. And then we'll get to a very important reality check.
Just look at this. The improvement is pretty dramatic. This chart shows the whole story, where we started with that low baseline score back in Phase 1 and the peak performance we hit later on. It just goes to show how powerful this step-by-step training is. But here's something really interesting. The absolute best performance? That actually came back in Phase 4. It just proves how incredibly important it is to make the model tough enough to handle that real-world digital camouflage.
And here it is, the final number. a peak score of 0.8217. Now, in the world of AI detection, that's a big deal. That's a really significant success. It's the culmination of this entire long training pipeline. A clear win for the whole method, but, like I said, there's a twist.
Okay, so here's the crucial point, and the scientists are super upfront about this. This whole experiment, it was a highly realistic simulation. They used synthetic data that was built to perfectly mimic the real thing. Now you might be asking, why do that? Well, the goal was to prove that the method itself, that 10-phase training pipeline, actually works. So this isn't a failure at all. It's a really important and honest part of doing science. You could call it the final dress rehearsal before the detective faces the real enemy.
Which, of course, brings us to the future. Our detective has definitely proven its potential, but the job is far from over. This whole fight against deepfakes, it's basically a non-stop arms race. The case, well, it never really closes. And you know what? The blueprint for this detective already has its next chapters planned out. What's next? Things like integrating with official standards, like C2PA, that create a verifiable digital paper trail for all media. They're also looking at new techniques like federated learning, which is a clever way for the AI to learn from data without compromising anyone's privacy. And, of course, expanding its skills to catch fakes in a whole bunch of different languages. So yeah, this digital detective is really just the beginning.
And that leaves us with one last big question to chew on. This blueprint proves we can build some really powerful tools for finding the truth. But let's be honest, the tools for creating fakes are also getting better and faster and way easier for anyone to use. So, in this constant, escalating arms race between creating fakes and detecting them, who do you think is actually winning?